Good evening and welcome back, guys. Today we are going to learn how to solve linear equations, write expressions, the difference between expressions and equations, and finally we solve literal equations. So to start our lesson, I have a warm-up. So the warm-up is from the lesson from last time. So some of you had question on long division. So we'll take the first 5 or 6 minutes on that. So everyone try the warm-up first. I'll give you 3 minutes. Then after 3 minutes, we'll discuss about the warm-up. Excellent, Norma, you already have the answer. Okay, good. So try the warm-up, work on it. Then we'll do it as a class, okay? So when you finish, just type your answer on the chat. Okay, I'll send you the link, Richard. Did you give me the date or email me the date? I'll send you the link. Okay, guys, 1 more minute. Try the warm up, then we'll do it as a class. So I won't take just 5 minutes, not more than that. So this is what we studied last time, this long division. Remember, polynomial has to be in standard form. Sometimes if they miss a term, you put 0 x to the power of n. Then you perform long division like we do long division in numbers. Find any factor which goes into the polynomial, you multiply, then switch the sign or subtract the product from the polynomial, and you keep doing that, these 3 steps over and over. Okay, guys, the almost time is up, so let's do okay. I will post the recording on Canvas. That solves the problem. Okay, you're welcome. Okay, now let's do this warm up. So first, you have to write the equation in standard form. It has to be because it doesn't have x squared term. You have to add 0x squared, then minus 9x plus 2, and this is divided by 3x minus 2. So we know the way we set up long division. You put the polynomial inside here, 3x cubed plus 0x squared minus 9x. So the 0x is like a placeholder, so it doesn't change the polynomial. So you have 3x minus 3. The divisor goes outside. So the first factor we look at is 3x cubed divided by 3x. So 3 cancels 3, and x cubed divided by x is x squared. So that x squared goes up here. Then you back multiply. So this way you multiply. So x squared times 3x is 3x cubed. And don't forget to change the sign. So change the sign here. or subtract. So when I say change sign and add, it means subtraction. X squared times -3 is -3x squared. I will change it into plus. Don't forget that step, okay? And now add the two polynomials. So this will cancel out. So 0 plus 3 is 3x squared minus 9x plus 2. So you just bring down -9x and 2. So the next factor will be 3x squared divided by 3x. So 3 cancels 3. X squared divided by x is x. So the x goes up here plus x. Back multiply x times 3x is 3x squared. We change it into minus. X times -3 is -3x. And we change it into plus. Don't forget to switch the sign. Then you add the two polynomials. You have, this will cancel out, -6x plus 2. So the last factor will be -6x divided by 3x. We always divide by the leading coefficient in the divisor, which is 3x, the leading term, I mean. So this will be -2. X cancels x, so you have -2. So the -2 goes up here. So we have -2 times 3x is -6x. We change it into plus. -2 times -3 is 6. Change it into -6. Then we add the 2, so this gives you -4. Okay, that's the remainder. And the answer or the question is x squared plus x minus 2 minus 4 over x minus 3x minus 2. Excellent. So we have the correct answer by Norma. Excellent. Okay, let's start today's topic. Today we are going to solve simple equations. That's the first objective. The second objective will be solving literal equations. So in this topic, we have three objectives. The first one is to understand the difference between algebraic expression and equation. What is an algebraic expression? What is an equation? The second one is translate verbal statements into symbols that represent the situation. So you have verbal statement, we can change it into expression or equation. Okay, then we will master techniques to solve equations. Okay? So we'll see starting from a one-step equation up to more complex equation. Okay. Now with that, let me give you some vocabularies. The first vocabulary I would like to talk about is algebraic expression. Algebraic expression is a collection of variables and constants joined by arithmetic operations. So any variable and numbers combined by arithmetic operations like addition, multiplication, division, and subtraction. All those arithmetic operations is called algebraic expression. For example, if I say 3x minus 1, this is algebraic expressions. There is multiplication, there is subtraction of variables and numbers, or for that matter, x, y, z plus m. This is also expression. We have like 4 variables. The number of variables does not matter. So all you have to remember is it is just a product or a sum and subtraction or division of different variables and numbers. It's called algebraic expression. Now an equation is two algebraic expression with equal sign. If we equate two algebraic expression, it's called equation. So you have 3x, for example, we have these two expressions. If I say 3x minus 1 is equal to xyz plus m, this now becomes equation. Okay, we are equating two expressions. So equations will have equal sign. That's the difference. So the equal sign will differentiate between expressions and equations. So any expression does not have equal sign. Equations should have equal sign. When you see equal sign, automatically it's equation. When you see just variables and numbers, it is just expression. Now the next one is solution. So the solution of an equation is the value that makes the equation true, or the statement true. What x value makes this statement true? That's the solution. Yeah. What, for example, if let's say equation x plus 1 equals 4. What number x makes this statement true? That's the solution. For example, 3 plus 1 is 4. 3 plus 1 is 4. So x equals 3 will be our solution. The number 3 makes this expression true. So x equals 3 is now our solution. So these are our vocabularies. So algebraic expression, equation, and solution. So to identify between algebraic expression and equation, look for equal sign. If you see equal sign, it is automatically equation. If you don't see any equal sign, it is expression. Okay. I think this is not something new for you guys. Let's move on to how we can rewrite statements into expressions and equations. So I'll do this three statements. I'll change them into equation. Then I'll give you three expressions and you change them into equation. Okay. So the first one says a number decreased by 7. So decreased, take away, minus, those represent subtraction. So when I say a number, that's unknown. So whenever you see something like a number which is unknown, we use a variable. Let's use x. It is decreased by 7 minus 7 equals 12. That's it. That's your equation. A number decreased by 7 equals 12. So we know this number should be 19 because 19 minus 7 is 12. So the way we can solve it is we undo the operation. So the x has to be by itself. So if I add 7, so the 7 will be cancelled out. Negative 7 plus 7 is 0. That's how you solve equations. You undo operations. X equals 19. So we'll come back to that. But for now, the expression is, the equation is x minus 7 equals 12. So we can change it into equation. Now, if you see the second one, a number divided by 2 equals 7. A number, so again, we don't know that number. A number divided by 2 equals 7. So what number divided by 2 will give you 7? I think you guys already know that. 14 divided by 2 is 7. So the way we solve it is we multiply both sides by 2. Okay? So that we can get rid of this 2. When you have numbers in the denominator, that's division. We undo division by doing multiplication. So you do the inverse operations. So x equals, this is 14. So the expression is x over 2 equals 7. And the solution is x equals 14. Now let's see, don't worry about solving the equation. So our objective is to write the statement into an equation, changing the statement into an equation. Now let's see the next one. 3 less than twice a number. So there is twice a number. A number, you can use any variable, but I choose x because we usually work with x. A number, 3 less than twice a number. So 3 less, so you have to take away 3 equals 1 more than a number. 1 more than a number. X plus 1 or 1 plus x is the same thing. 1 more than a number. More than represent addition. More. So that's the equation. And we'll learn how to solve this. Okay. Next. Any question? Okay, now I want you to try this 3 and write the equation. Try this 3 and write the equation. So I'll give you 2 minutes for each. I think 1 minute is enough also, but let me give you 5 minutes on average. So write your answer: 1, the expression; 2, the expression; 3, the expression on the chat. So 16 less than 3 times a number equals 2 added to 4 times a number. And number 2 says 5 less than 4 times a number equal 1/5 of a number. 1/5 of a number. And the last one says half a number equals twice the difference of a number and 12. Twice the difference of a number and 12. So you have to write the expressions. And when you're done, type the answer in the chat. We'll see, Jasmine. So anyone with different answer, please type on the chat. Then we'll discuss about it. Okay, good, Deva. Anyone with different answer? Okay, I think we can go over the first one. So it says 16 less. Did you guys see that? 16 less. So you have to take away 16. So there is a number 3 times a number, then 16 less. I know the wording is a little bit confusing, but it says 16 less equals 2 plus 4x. Can you guys see it now? Yeah, you had it back. Yeah. So because it comes first, it doesn't mean it has to be first. So it says 16 less, so you are taking away 16 from the given expression. So 3 times a number, that is 3x, then you have 16 less. Okay. What about number 2 then? Good, Deborah. So number 2 is somehow similar. So you should be able to do that, number 2. Okay, let me see. Good judgment, but the 5 is by itself. It says just 5 less. It doesn't have x. I think it's just typing error. Yes, excellent. But you have to be careful when you write the fraction. So when you say 1 over 5x, it is totally different from 1/5 of x. And I would like to show you the difference. So when you say 1 over 5x, this is totally different from 1/5 of x, 1 over 5 times x, or what, just 1 over 5x. So 1/5 of where the x has to be in the numerator. Oh, sorry. So 1/5 times x. So it is the same as x over 5 if you want. But if you write the x in the denominator, it will be a little bit different because it becomes 1 over 5x rather than 1/5 of x. I know, I think you got it right, but it's just when you write, you have to clarify. So your answer is good, but and Norma, I don't know why you put 0.05. 0.05 is, I think, 1 over, it's a very small number. Or did you correct it? Let me see. Yeah, good. Excellent. And when you write, don't write 1 over 5x. It's just 1 over 5 times x, or just x over 5. Or use parentheses. That way, the confusion, let me show you what I mean by that. If you write it this way, that's great. 1 over 5x, or 4x minus 5 equals x over 5. That's also perfectly fine. Okay, it's just because this is something different. You guys see that now, the 5x. Okay, the last one. Oh, we went a little bit over 5 minutes. Okay, let's go to number 3. Half a number equals twice the difference of a number and 12. So for this one, you have to follow order of operation. So you have to think about the order of operation. Which one we do first? Do we multiply, or do you see parentheses? Right, number 3. Yeah, it is 1 times x. It becomes x over 5. So yeah, technically we can replace 1 by 5, and sorry, by x. 1 times x is x over 5. So 1/5 x is the same as x over 5. Okay, anyone for number 3? Be quick. We're taking time. Okay. Okay. Okay, good. So there's a slight correction on this one. Sorry. Also, if you see here, it says twice the difference of a number and 12. So we have the difference of a number and 12, which will be multiplied by 2. So twice of that. So this should be inside a parenthesis. The difference of a number and 12. X minus 12 will be multiplied by 2. So this is what twice the difference of a number and 12 looks like. And it is equal to half a number, x over 2, half of a number, or 1 over 2 times x. So if you write like this, it's sort of perfectly fine. Half a number equals twice x minus 12. Difference of a number and 12. Okay, do you guys see the difference now? Yeah, so yeah, exactly. So the difference of a number and 12 is just a single number, so it has to be inside parentheses. Okay, excellent. So we are done with the first objective, which is writing an expression into equation. So a given statement into equation. Now let's move to solving equation. Okay. Here we go. First, I'll start from one-step equations. So when you have equations with a single operation, you undo that operation. So if you have addition, you perform subtraction. Vice versa. If you have subtraction, you perform addition. So our objective is to let the variable by itself on one side of the equation. So isolate the variable. That's the objective. Isolate the variable. To do that, you have to undo operations. So if you have multiplication, you do division. And it is vice versa, okay? It goes both ways. Okay, now let's see the first equation. If you see here, we have x plus 9, so I have to take away 9 to isolate x. Now x become by itself, 9 cancels 9, and you have negative 6. So x equals negative 6 is the answer, straightforward. And if you see the second one, we have multiplication. We have division, have to multiply by 7 both sides, so that this will be cancelled out. So x equals 14 times 7, which is 98. Very simple. So one-step equations are simple. So what do you think is number 3 and number 4? Just type the numbers. I think you don't need. So what is negative 2x equals 14 and x minus 2 equals 11? So to get rid of confusion, let's say this is number 3 and this is number 4. This is a one-step equation. So x equals negative 7, excellent judgment. And number 4, excellent, x equals 13. So all you have to do is divide by negative 2 here. So x equals 14 divided by 2 is 7, and we have positive divided by negative is negative. Here we add 2, so x equals 13. So these are one-step equations. Next, we see two-step equations. So two-step equations involve either multiplication and division, then either addition or subtraction. So when you solve equations, you go in reverse order of operation. So first you have to undo either addition or subtraction, then undo multiplication or division. So these are the steps. Just do not start by undoing multiplication or division. That doesn't work. So what I have to do is first undo addition or subtraction. So if you see example here, 3x minus 7 equals 14. First, I have to undo subtraction. So I have to do addition. So plus 7 will get rid of the negative 7. So I have 3x equals, this is 21. Now I have to undo multiplication. So I have to do division. So I have to divide both sides by 3. So x equals 7. So the steps are just undo addition or subtraction first, then undo multiplication or division. Okay. Very good, Luz. Now try the second one, x over 2 plus 5 equals 8. I'll give you 2 minutes. And write your answers on the chat. Okay, x equals 4. So 4 over 2 is 2. 2 plus 5 is 7. Okay, Lewis has 6. Okay, 6 over 2 is 3. 3 plus 5 is 8. So you can check your answer also. Yeah, very good, Jason. So you got it right now. So always remember, you can substitute the number into the equation and it has to give you a true statement. So usually, yeah, that's fine. Usually, if you want to know if you are doing the problem right, what you can do is just plug in the number into the equation and it should give you the correct answer. Okay, very good. So x equals 6 looks like the correct answer from your answer. Let's do it. So first I have to undo addition or subtraction. So I have to take away 5 because we have addition here. So x over 2 equals 8 minus 3 is 8 minus 5 is 3. Now I have division. To undo division, we do multiplication. So multiply both sides by 2. So x equals 3 times 2, which is 6. Okay, excellent. Now, if you know how to do two-step equation, after this is just simplifying expressions and reduce it into a two-step equation. Then solve it. So let's see multi-step equations. So there are different multi-step equations, equations with variable on one side, variables on both sides. So I'll do equations with variables on both sides of the equation. Now, when you have variables on both sides, so what you have to do is move the variable which is smaller, move it to the other side. What I mean by that is, for example, if you see this equation, you have 2x minus 3 equals 1 plus x. So you have to move the x to the other side. So the way we do it is we undo the operations. Here we have plus x. So I have to take away x so that the x will move to the left. So you have to get rid of the variable from the right hand side. So the variable has to be on one side. That's basically what I mean by moving the variable to the other side. So to do that, we undo the operations, plus x minus x. So I have 2x minus x is just x, minus 3 equals 1. Now it becomes one-step equation. So to undo subtraction, we do addition. Addition here. So x equals 1 plus 3, which is 4. Okay, that's how we solve equations with variable on both sides. Okay. Now, would you try the next problem, or should I do it? Okay, let's do the problem together, and I'll give you time on the next examples. Now, the same thing can be done here. I have negative 3x. Negative 3x is smaller than 4x. So what I will do is I'll move the 3x to the right, so I can add 3x. So you do the inverse. So you have minus 3x, you do add 3x and 3x here. So this will cancel out. I have 16 equals 3 plus 7x. Now this is a two-step equation, which is you can rearrange it and write it as 7x plus 3 equals 16. It's the same thing. Okay. So some students prefer to work with variable on the left-hand side rather than variable on the right-hand side. But you don't have to do that. So here I have to take away 3, minus 3 here, minus 3. So we have 13 equals 7x. Then divide by 7. Divide by 7. That is x. So x equals 13 over 7. Okay, simple. You know, once you have the variable on one side, you will have two-step equation, and it's easy to solve two-step equation. Any question on these examples? Now, multi-step equations can have parentheses. Sometimes they have parentheses and very long expressions. So we do the same thing. So what you have to do is first simplify the expression. So simplify, we have to get rid of the parentheses. So I have to distribute the 2 here. If you have two parentheses, you have to distribute the two parentheses also. So 2 times 3 is 6, minus 3 times 3 is 9x, equals 2x minus 9. So negative 9x is less than 2x. So I will move the 9x to the right. So I will add 9x so that you will get a positive coefficient for x. So 9x will be cancelled out. So 6 equals 11x minus 9. So two-step equation, 11x minus 9 equals 6. So I have to undo subtraction. I have to add 9 on both sides. So 15 equals 11x, then divide by 11. Two-step equation. That's simple. So x equals 15 over 11. Okay, that's how we solve equations with parentheses. Any questions so far? Let me see. Okay, now try the next example. It says 4 times 2x plus 1, inside of parentheses, equals 3 times x minus 3 minus 7. I don't know who shared this. You wouldn't put x equals 14 over 11. I don't know for which problem you are talking about, but here we have 15 over 11. No, it doesn't reduce to 14 over 11. No, it doesn't reduce to that. It is 15 over 11. Yeah. So you have to distribute the two parentheses to get rid of the two parentheses, and you have variable on both sides, and you solve it. So you have -4 plus you have -4. So just plug in -4 and see if it gives you the same numbers on the left and on the right. So I can do that on my own. So 2 times -4 is -8 plus 1 would be -7. So 4 times -7 is -28 on the left hand side. So on the right hand side, I have 3 times x minus 3. So x is -4. So -4 minus 3 is -7. 3 times -7 is -21. Minus 7 would be -28. So that seems the correct answer. Okay. Anyone's different answer? Type on the chat. Yeah, just write it in proper fraction. You don't have to write it in mixed fraction, so it has to be in proper. Whatever, if you have to reduce it, you have to. Sometimes the numbers can be reduced, but this number 15 over 11 cannot be reduced because they don't have any common factor, so it cannot be reduced. Okay, guys, time's up. Let's do the problem. Yeah. So if you can reduce it, you have to reduce it. If you can't reduce it, you just keep the answer. So 15 over 11 cannot be reduced. Okay. Reduced. So here, distribute the 4, distribute the 3. So I have 4 times 2x, which is 8x, plus 4 times 1 is 4, equals 3 times x is 3x, 3 times negative 3 is negative 9, then minus 9. So you minus 7. That's 7. So you combine these two, and it will give you negative 16. And I have 3x, I have 8x plus 4. Now I have to move the variable to one side. So I see 3x, which is less than 8x. So I'll take away 3x on both sides so that the variable will be on one side. So you have 5x plus 4 equals negative 16. So this will be considered. So I have to take away 4. Just undo addition. Minus 4, minus 4, 5x equals negative 16 minus 4 is negative 20. So let me move this here. 5x equals negative 20. So I have to undo multiplication. You have to divide by 5. So x equals negative 4. 20 divided by 5 is 4. Negative divided by positive is negative. Okay, that's the correct answer. Any question? Excellent. So we have the correct answer. We move to the next one. Now, the next there are different form of equations in linear equations which result in either a single solution. So far, if you see, we had a single solution. Sometimes you may get many solutions, infinite many solutions. That means any number in the real number set will satisfy the equation. Or sometimes you get no solution. No number will satisfy that equation. The equation will be always wrong. Or the equation will not be satisfied by any number. So there are two conditions. One, if you have a, after simplifying, if you have a equals a or 0 equals 0, this kind of equations will give you many solutions. Okay, we call them miscellaneous solutions because either will give you many solution or no solution. So if after simplifying, so first case, if a equals a, then you have many solutions. If you get a equals b, which is a false statement, a cannot be equal to b unless a equals b, which is, which is false. If you get a false statement, you have no solution. Okay, so I have two examples for that. Now, what I do is you just follow the steps we have been doing, and at the end, you'll get expressions without a variable. So you get a number equals another number. If the two numbers are equal, you have many solutions because it is a true statement. It will be always true statement. Any real number will give you a true statement. If the two numbers are not the same, any real number will give you a false statement. Okay, let me show you these two examples. So I have on the left 2x plus 2. On the right, I have to distribute the 2. So I have 2x. 2 times x is 2x. 2 times 1 is 2. Now I have to get rid of the variable. So I have to subtract 2x from both sides. So to move the variable to the left, I take away 2x. So this cancels out. This also cancels out. They're 0. So we are be left with 2 equals 2. So this is a true statement. Okay? Any real number will make it a true statement. It doesn't matter what number you pick. It will always be a true statement. Okay? So if you have a true statement, that means you have many solutions, infinite many solutions. 2 is equal to 2 always, with regard of x value. Any x value you have, it is a true statement. Okay. Now let's check the second one. So if you see here, we have x plus 1 equals x plus 2. So we take away x from both sides to move the variable x to the left. So x cancels x. Here also x cancels x. I have 1 equals 2. This is a false statement. 1 is not equal to 2. So this is a false statement. So if you have a false statement, you have no solution. Any number you have, any x value you have, it is always a false statement. No solution. So it cannot be satisfied by any real number. So this equation cannot be satisfied by any real number. So the solution is either infinite many solution or no solution. So for linear equation, you can have a single solution. You can have many solutions. You can have no solution. It is many solutions. So the first one, 2 equals 2 is true. So it is many solutions. The second one is not many. It is no solution. Yes, you are right. So 2 equals 2. Any number, for example, it can give you at the end 3 equals 3. If it is a true statement, it is always many solution. Or 0 equals 0 would be many solution. But if you get a number like 1 equals 2, which is a false statement, 1 cannot be equal to 2. In that case, you have no solution. No real number will satisfy that equation. Okay. So we're done with this unit. Topic. Let's move to something called literal equations and formulas. How to solve literal equations and formulas. So 4.2 is the simple formulas and literal equations. So our objective is to successfully manipulate and move around literal equations and solve for a variable, one of the variables. So literal equations are equations with more than one variable. Okay, equations with more than one variable. So let me give you the definition. So write down the objective and I'll give you the definition. Now, vocabulary. So literal equation is an equation with more than one variable. So this is important, more than one variable. So you will have more than one variable. So linear equations usually have one variable. So far we've seen x, 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 everywhere x. But now you will have more than one variable. So formulas are excellent example of literal equations. Formulas are formulas or literal equations derived from real world situations. Like for example, the voltage is current times resistance. So it is the how we can measure voltage. So this is a real world situation. The current is flowing in a wire. If you know the resistor of the wire, you can find the voltage generated in the wires. So that is called literal equation, which is also a formula. So if the literal equation represents a real world situation, we call it formula. Okay. Sometimes literal equation can be just any random equation. If I say, let's say f equals 2x squared y plus m, and I don't know x, y, and m, they're not real parameters. This is just literal equation. Okay. It has more than one variables, and it is equation because it has equal sign. But some formulas are derived from real world equation. For example, force is mass times acceleration squared. F is equal to m. So this is real world. There's mass times acceleration squared. So this is a physics problem. If you don't know what is mass, what is acceleration, don't worry about it. Or if the famous equation E equals mc squared. So the same, energy equals mass times the square of the speed of light, mc squared. So matter can be changed into energy. That's basically what this formula says. So this kind of literal equations are called formulas because they represent real world situation. Okay. Now, once you understand what is literal equation is, now let's see how we can manipulate and solve literal equation. Now, in literal equation, you'll be given the variable you are going to solve. So I give you an equation and I'll say solve for this variable. If so, you have to specifically figure out what you are looking for. Okay, unless it is specified, there is no way you can solve the equation, and it doesn't make sense. So when we say solving literal equation, it's just rearranging the equation so that you'll have the variable you are looking for by itself on one side of the equation. For example, if I want m by itself, I have to divide here by c squared, so that m becomes by itself. So the mass m is energy over speed of light squared. So that's basically what I mean by solving. Okay, now let's see examples. So when you see examples, you understand. So solve the formula for a given variable. So the given variable is b. So we are going to solve for b. So we have a, y, 2, and c. A, y plus b equals 2c. Now, my objective is to put b by itself on one side of the equation. So to do that, I have to take away ay. So ay has to go to the other side of the equation, minus ay. It's like solving one-step equation. But the difference is now we have variables rather than numbers. So we take away ay, cancels out. So we have b here. Because these are not like terms, so they will stay 2c minus ay. That's it. So b is 2c minus ay. That's what solving literal equation means. It's just rearranging and figuring out the b in terms of a, y, and c. Any question? I mean, before we move to the next example, do you have any question? So I'll show you two more examples, because this is literal equations, a little bit different. Then we'll do two equations as a class. Okay, I'll show you two more equations and I'll give you time to work on two additional equations. So they'll be a little bit complex and it builds up. So this is very simple, it's just one step equation. We just took away ay and we find b. Now let's see the second one. The second example says this is a formula. A conductor and material that permits the flow of electron. Resistance is a measure of the resistance of that flow of electrons. At a given temperature, the resistance of a material is dependent on the type, length, and cross-sectional area of the material. So P represents the material type. There should be some constant which represent each material. For each material, you have different P value. L represents the length. A represents the cross-sectional area of the material. So this is the equation. The resistance R is equal to P times L over A. So R is the resistance. So this is the formula. P is the some constant, which is a property of the material. L over A. So the L is the length and A is the cross-sectional area. So it says solve for A. We are solving for A. Now, before we start solving for A, if you see this equation, there is division. Usually, whenever you see division, undo that division. So first, I have to multiply by A, so that A will be in the numerator. So this A will be cancelled out. So I have AR equals PL. Now, if you see here, A is multiplied by R. So I am interested to solve for A. That means I want A to be by itself on one side of the equation. So I have to get rid of R. To do that, we undo multiplication by R. We do division by R. So R would be cancelled out. So A equals PL over R. Very simple. Okay, this is a really simple equation. Just think like you're solving linear equation. So you undo addition, you undo multiplication, you undo division. Any question on this one? Okay, let's do one more example, then I'll give you time to work on two more examples. We'll take more time on those two. Okay, now the next one says, in the study of a force on a wing of an aircraft, the equation m equals r times L minus x is used. So I don't know exactly what parameter m means, parameter r means. L, I can suspect this the length of the wing. X can be the width of the wing of the airplane. R and m, those are force and some other parameter. So the m equals r times L minus x, and we are asked to solve for L. Now, we can approach this problem in two ways. One, we can distribute the R and then solve for L. Or we can start by dividing by R so that Lx will be by itself. L minus x, I mean. Divide both sides by R. So you have m over R equals, the R cancels out, L minus x. So this is just one step equation, L minus x. So I have to undo subtraction. So I have to add x on both sides. Add x on both sides. So the left hand side becomes m over r plus x and equals to L. So L is m over r plus x. So this is just right away when you start dividing by r, and it makes it simple, the problem simple. But sometimes you can also solve the same problem by distribution. So m equals r L minus x. If you have this solution, is exactly the same. So distribute the r. So you have m equals rl minus r times x is rx. So we are solving for L. So I have to get rid of rx. So I have to add rx on both sides. So you have m, this is plus rx equals rl. So this is multiplication by r. I will divide by r both sides. So L equals m plus rx over r. So this both these expressions are exactly the same. Because if you divide each one of them by r, you'll get the same expression. So it's m over r. If you divide each by r, rx over r. So r cancels r. So I have m over r plus x. So they are the same expressions or similar expressions. Okay, so whichever is easier for you, just do that. Okay, when you have literal equation, and if you have a parenthesis, you can distribute and solve it, or just divide and then solve for the expression inside. Any question? Does this make sense? Do you see the difference between the two and the similarity between the two? Oh, no. That's right. Your answer is correct, Norma. Will not be marked wrong. So both these expressions are the same. Yeah. Yeah. So just do the left hand side. So but the two expressions are the same. So if you see here, after you have r divided by r, divide each one of them by r, so you still get this expression. Okay. So usually check, because you can try unlimited times on my MATLAB. There is no restriction on the assignment. So try both of them. If it gives you, it says wrong, so stick to one of them. Okay. So type both of this Okay, and see if it gives you on it should give you I mean it should be the correct answer, but if it doesn't, stick to one of them. Okay, so in this case you have to divide by r each one of them and simplify it to m over r plus x. Okay guys, now we are at 7 o'clock, so we have 2 questions and 20 minutes. So what I will do is I'll give you 5 to 6 minutes for each question, then we'll do the problem as a class the remaining 3 or 4 minutes. Then we'll go to the next question again, 5 to 6 minutes, then we'll do the problem as a class within 3 to 4 minutes. Okay, now let's go to the next question. Here is the problem. So right now it is 701. So work until 706 or 707. You can say 707. Then we'll work on the problem together. So in analyzing the transfer of heat through a wall, a solar engineer must solve the equation. This is the equation. Q is energy or heat energy. K times A times B minus C over L, and solve for B. That's the question. Solve for B. Solve for B. Okay, start working now. 5 to 6 minutes, then we'll come back and do it as a class. When you finish, write your answer on the chat. You guys already have the answers. QL over KA plus C, excellent normal. QL over KA, C, excellent. Your questions are good. So we have time. So everyone try the problem. So Q over AK. So we start by dividing. Richard, okay. Okay, Norma. Yeah. So you can stay after class. Okay, guys, so I have small correction. So Luz and Norma, your answers are right, but when you write the variables, it has to be in the right form. So if it is a small letter, it has to stay small letter. So small q and capital Q are something different. So if it is small q, it has to stay small q. If it is capital letter, it has to stay capital letter, because the letters represent something different each time. Okay. Okay, I'll do it, Richard. I'll do it. Just one more minute. So let's see if there is anyone who can try. Okay, now this is how you solve this problem. So usually, if you have so this is Q uh, equals, it looks like 9. So let me write it this way. Sorry about that. So Q equals KA, capital A, capital B minus C over L. Now, always if you see a division, get rid of the denominator. So I have to multiply L both side by L, so that this will be cancelled out. That way the expression becomes easy to solve. So I have LQ equals KA and B minus C. So I'm looking for B, but I see multiplication here by K. So I have to get rid of that multiplication. So KA divide by KA. Okay, so that this will be cancelled out. So LQ over KA equals B minus C. So we have one step equation, which is subtraction minus C. So I have to undo subtraction. So I have to add C on both sides plus C. So this would be B by itself. And I have LQ over KA plus C. That is the correct answer. Please do not change the letters. If it is capital letter, it says capital letter. L is capital letter, A is capital letter, B and C are capital. So it means different, something different. So check in your my math lab. So when you put the answer, it has to be in the correct letter format. If it is capital letter, you keep it capital. Any question? Okay, good, Richard, you got it. Now let's go to the last one. So the last one is a little bit complex, so I'll give you more time. Now, here we go. This is the last example I have. So solve for S1. So you have S1, S2, and variable A and variable C. So all of them are in small letters. Okay, now solve for S1. I'll give you a hint, distribute. So get rid of this and distribute the 3A. Okay, that's the hint. And we'll come back after 6 minutes on 7:50. Okay. So Richard, the S1 has to be by itself. Still you have A in front of it. You have to solve it after all. That's the whole point of the problem. Say solve for S1. So you have 3 minutes, so that if you get the answer, just type it on the chat so that we can discuss about it. It's okay if you miss the problem. This is perfectly okay. So we learn from our mistakes and we have to try. That's the whole important thing in math classes. You have to try and try. So if you were in in-person class, I would let you do it in the board, or you can do it on a piece of paper and we can discuss about it. But here we are limited to a single board, and right now I'm presenting. So you have to show me your work. That's the only way I know you're trying the problems. Excellent, Lewis. So we have 3, but we have S1 on both sides of the equation. S1 has to be by itself on one side. It's okay if you don't know how to solve it, we can do that together. So we have 1 more minute. Oh, we're almost done. So S1 has to be by itself on one side. Okay, let's do the problem. So if you see here, I have AS1 plus CS2 on the left hand side. Now the right hand side, you have to distribute the 3A, so it becomes 3A S1 plus 3A times A will be 3A squared. So I'm solving for S1 and I see 2 S1s here and here. So I have to move the AS1 to the right so that I can subtract AS1 from both sides. What is 3AS1 minus AS1? Can you guys give me what is 3AS1 minus AS1? 2AS1. Excellent, Jasmine. So I have 2AS1 on the right hand side. So here CS2 equals 2AS1 plus 3A squared. So I'm solving for S1, but I see here addition. So you have to undo addition. Minus 3A squared minus 3A squared. So this gives you CS2 minus 3A squared equals 2A S1. So again, I see multiplication by 2A, so I have to divide by 2A, all of them, here, here. So S1 is C s2 minus 3a squared over 2a. Okay, that's the final answer. Any questions? It's just like a multi-step equation, linear equation. Any question? We have 3 minutes. If you have any question, I'll open the class for discussion. Yeah, I mean, just divide by 2a. It's just multiplication. When you see multiplication, you do division. When you see addition, you do subtraction. Okay? I know it looks very complex. It's basically the same linear equation. It's like solving linear equation. Instead of no, it doesn't work like that, Richard. If you divide by AS1, you are going to make the expression very complex. So when you divide by AS1, do you mean by I have to divide by AS1 or just by A? No, we said instead of subtracting AS1, I have to divide by AS1. But if you divide by AS1, the expression will be very complex. It doesn't simplify the expression. It has to be subtracted. Okay. Okay, guys, we have 1 minute. Any question? Any last minute question? So which chapter is covered in quiz 4? Quiz 4 is all about chapter 3 up 3.1, 3.2, 3.3, and 3.4. 3.5 is not included, the one from Tuesday. Division is not included. Jasmine, you can stay after class. So the rest of you, if you don't have any question, I'll see you guys next Tuesday. Okay, I'll see you next Tuesday.